Hello everyone. In this video we are going to discuss about Chemical Engineering GATE 2018 Process Instrumentation Dynamics and Control questions with solution. GATE 2018 question paper and the answer key link is available in my description box. You can download it. Question number 18. A first order process having a transfer function Gp is equal to 2 by 7s plus 1 is controlled by a proportional controller. What is the meaning of proportional controller? That is P controller with a gain of 3.2. Gain means that is a K or Kc. So the process time constant is in minute, that is tau is equal to minutes. Addition of the integral action. Integral action means that is acting as a PI controller with an integral time constant of 5 minutes. Integral time constant, that is tau I, leads to increase in. We have 4 options. First one offset, second one speed of response, third one order of the closed loop system, last one proportional band. So which one is the right option for this question? We will discuss now. Data Gp is equal to 2 by 7s plus 1, that is transfer function for process. P controller Kc value or K value 3.2, time constant is in minute. Addition of integral action, that is PI controller, time constant. So that is integral time constant tau I is equal to 5 minutes. So we have 4 options. The first option is a offset. Whether it is right or wrong, we will discuss now. The first option, offset. So for P controller and PA controller, what is the offset value? So this is the general block diagram of feedback control system. So here this is a set point, capital R. B is a measured variable. So what is E here? E is a error. So the K or Kc is a transfer function for, this is a Kc is right. So Kc or K transfer function for P controller. Capital U disturbance or this is the load variable. So here process transfer function 2 by 7s plus 1. Controlled variable or output, that is a C. Okay. So here the plus minus indicate there is negative feedback control system. So here this is the servo mechanism. So this is the under servo mechanism or servo control problem. So C of S by R of S. What is the formula C of S by R of S? For servo mechanism, for negative feedback control system, product of transfer function between C and R divided by 1 plus product of transfer function in entire loop. So here the product of transfer function between C and R, K or Kc into 2 by 7s plus 1 divided by 1 plus product of transfer function in entire loop, the same thing, 2k divided by 7s plus 1. Are you clear? Okay. So 1 plus this one. So rearrange this expression. Finally we get 2k divided by 7s plus 1 plus 2k. Okay. This is C of S by R of S. For P controller, the Kc value, that is given data 3.2. Substitute here. Find out the C of S by R of S here. So the C of S by R of S is equal to, after substituting the Kc value, 6.4 divided by 7s plus 7.4. So you see in the denominator part, 7 is plus 7.4. So what is a first order system? G of S is equal to the transfer function for first order system 1 by tau s plus 1. So here 7 is plus 7.4. You compare these two, denominator section and here the general equation. So here 7 is plus 7.4, here tau is plus 1. So what you do here, they take 7.4 outside. numerator term 6.4 divided by 7.4 whole divided by 7 by 7.4s plus 1. Okay. So 0.86 divided by 0.94s plus 1. This is C of S by R of S. Okay. This is the C of S by R of S for P controller. So generally unit step change in set point. Why? Because this part comes under servo mechanism. So we should take R of t is equal to 1. What about the R of infinity here? That is equal to 1. We want R of S. What do you do here? Take Laplace transform. So t domain goes to S domain. R of S is equal to 1 by S. Laplace transform of 1 is equal to 1 by S. So now we have R of S value. Already we have C of S by R of S. This expression is correct. So here substitute R of S value. What is R of S here? 1 by S. So what is C of S? C of S is equal to 0.86 divided by S into 0.94 S plus 1. Are you clear? Okay. So why? Because the R of S value is equal to 1 by S. So we want offset value. So the offset value R of infinity minus C of infinity. Already we have R of infinity, that is equal to 1. So we have only C of S. We want is C of infinity. What do you do here? We know the final value theorem is right. Final value theorem, limit of C of t is equal to here limit S tending to 0 S into C of S. So here in left hand side limit t tending to infinity, C of t is equal to. So here the t goes to infinity, C of infinity in left hand side. Right hand side limit S tending to 0 S into C of S. So here already we have C of S equation is right. Substitute here S into 0.86 divided by S into 0.94 S plus 1. Here S's are cancelled. So the finally substitute S value equal to 0. So here substitute the S value 0. What is the C of infinity value? 0.86 divided by 1. C of infinity is equal to 0.86. So now we have R of infinity and C of infinity. Substitute here, find out the offset value. Offset is equal to 0.14 for P controller. So addition of integral action. What about the offset? So the same diagram we should take. R is a set point, B is a measured variable, plus minus indicate the negative feedback control system, E is a error, GC of S is a controller transfer function, capital U is a disturbance or load variable, GP of S is a process transfer function, C is a controlled variable. Okay. So here for PI controller, what is a GC of S or transfer function? Kc into 1 plus 1 by tau by S. This is a transfer function for PI controller. So here the Kc value 3.2, substitute tau I, this is given data 5. Finally we get GC of S is equal to 3.2 into 5s plus 1 by 5s. What is the process transfer function? This is given data. We should take GP of S is equal to 2 by 7s plus 1. So already I said this is comes under servo mechanism. C of S by R of S is equal to product of transfer function between C and R, GC of S into GP of S, whole divided by 1 plus product of transfer function in entire loop. Entire loop the same thing, GC of S into GP of S. Now we have GC of S and GP of S value. So GC of S 3.2 into 5s plus 1 by 5s. Substitute here. GP of S 2 by 7s plus 1. So reduce this expression. Finally we get C of S by R of S. This is just rearrange this expression. After cancelling the common term, C of S by R of S is equal to 6.4s plus 1.28 divided by 7s square plus 7.4s plus 1.28. So this is the equation for C of S by R of S in PI controller. So here take R of t is equal to 1. Unit step change in set point, because this is comes under servo mechanism. So what is R of infinity? R of t is equal to 1 mean t tending to infinity, R of infinity also equal to 1. So we want R of s. What do you do here? Take Laplace transform. Laplace transform, t domain goes to s domain. R of s is equal to Laplace transform of 1 is equal to 1 by s. Now we have R of s. R of s is equal to 1 by s. So substitute here, C of s is equal to, already we have C of s by R of s na. You replace R of s here, substitute 1 by s. C of s is equal to 6.4s plus 1.28 divided by s into 7s square plus 7.4s plus 1.28. So this is C of s equation. But we want C of infinity, is right? So we know the final value theorem. Limit t tending to infinity, C of t is equal to limit s tending to 0, s into C of s. So here first one C of infinity. So C of t mean t tending to infinity, left hand side C of infinity, right hand side s into C of s. Already we have C of s expression here, is right? Substitute this expression here. So substitute this expression, s into this expression, is right? 6.4s plus 1.28 divided by s into 7s squared plus 7.4s plus 1.28. So s are cancelled here. Finally, after substituting the s value, numerator term 1.28 divided by denominator term also 1.28, we get C of infinity is equal to 1. Now we have R of infinity and C of infinity. R of infinity is equal to 1. C of infinity also equal to 1. So what is the offset here? Offset formula, R of infinity minus C of infinity. Both values are 1, is right? So finally we get the offset is equal to 0, is right? So for P controller, offset value we have, is right? For PI controller, offset value equal to 0. Okay. So addition of integral action reduces the offset to 0. So this option is a wrong option. Here the first option, yeah, this is offset. Offset is a wrong one, is right? So the addition of integral action reduces the offset to 0. This is not the correct option. So the second one, speed of response, whether it is right or wrong, we could check now. The speed of response, you see here for P controller, what is the order of the system? So the P controller, what is the C of s by R of s? Here C of s by R of s equal to 0.86 divided by 0.94 s plus 1. Yeah, second one, I explain here. The second one, speed. So here speed of the response. Speed of the response for P controller and PI controller. Speed of the response. So speed of the response. First one, P controller. P controller here, this is P controller. Here C of s by R of s. C of s by R of s is equal to C of s by R of s. Already derived one. Refer the previous one. C of s by R of s is equal to, here 0.86 divided by 0.86 whole divided by 0.94 s. 0.94 s plus 1. Okay. So this is C of s by R of s for P controller. So this is comes under the first order control system. Why? Because this is 0.94 s plus 1. This is tau s plus 1. So here this is tau value 0.94, is right? 0.94 tau s plus 1. This is 0.94. So this is speed of the response for P controller. This is the first order, is right? This is the first order control system. Tau value 0.94. How it is come 0.94? The general first order control system, this is tau s plus 1, is right? This is tau s plus 1. So the tau value 0.94. 94. Okay, this is the P controller. What is PI controller? For PI controller also already we have is right, C of S by R of S expression. So that expression comes under the second order control system. This is PI controller. So C of S by R of S. What is C of S by R of S here? C of S divided by R of S. So C of S by R of S that is equal to this equation 6.4 S plus 1.28. So here is 1.28 divided by 7S squared plus 7.4S plus 1.28 is right, 1.28. This is this expression taken from previous slide. Go back. Yeah, this is the expression is right. C of S by R of S. 6.4S plus 1.28 divided by 7S squared plus 7.4S plus 1.28. This is C of S by R of S for PI controller. But here this is the second order control system. So this is not the correct form for second order control system. What do you do here? The same term 6.4S plus 1.28. Okay, so here 1.28 divided by, yeah, this denominator term divided by 1.28. 7 divided by 1.28 S squared plus 7.4 divided by 1.28 into S. 1.28 into S plus 1. Okay, so this is the correct form of second order control system. What is this second order control system? K divided by G of S is equal to, this is a transfer function for second order control system. G of S is equal to K divided by tau squared S squared plus 2 pi tau S plus 1. 2 pi tau S plus 1. Okay, so this is the general expression. You compare general expression and our equation. So what is a tau value here? So tau squared is equal to 7 by 1.28. Okay, 7 by 1.28. Okay, so here what is the tau value? So find out the tau value here. So what is the value here? 7 by 1.28. So this value here 7 divided by 1.28, this is 5.46 is right. So this 5.46, so the root value, so tau squared is equal to 5.46. So the root of 5.46, 2.33. So 2.33. So this is the tau value for PI controller. Okay, so what is this? Is the second order is right. This is second order control system. So for speed of the response, P controller tau value 0.94 for PI controller. So addition of integral action tau value 2.33. So conclusion for this option, second order system slower than the first order system. Okay, so that's why here this option 2 also wrong. This is also wrong, the speed of the response. So this is also wrong. So third one is order of the system, we will discuss later. So last option, that is proportional band, whether it is right or wrong, we could check the proportional band. So the proportional band generally PB is equal to 100 percentage divided by gain value, is right. This is 100 percentage divided by gain value. So this is a general formula for proportional band. So the addition of integral action, whether it is increase or decrease, that is a proportional band. So general concept, integral control action is widely used because it provides on important practical advantage, the elimination of offset. So here offset value for PI controller that is equal to 0, is right. So integral control action widely used because it provides an important practical advantage. So the elimination of offset. To understand why offset is eliminated, so in order for the controlled process to be at a steady state, the controller output that is P must be constant. So generally this is the PI controller. So here this is input is E of t, output is P of t, the controller output, this is E of t, this is the P of t. So here controlled output P must be constant, so that manipulated variable is also constant. Because of this reason, generally the proportional band increased, the change in the manipulated variable will be smaller for a change in the deviation. So because of this reason, the proportional band option also wrong. The proportional band option also wrong. Okay. So here generally this option is a right option. So why? Because you see here order of the system from this. What is the order of the system for P controller? P controller order of the system is a first order system, is right. This is a first order. So what is a PI controller? Addition of integral action, this is second order control system. So here the order of the system increasing. So that's why this is the right option for this question. Order of the closed loop system increase. So the addition of the integral action, order of the closed loop system increase. Okay. So increases. Are you clear? Okay. So option C is the correct option for this question. For further related videos, you can like, share and subscribe my channel. Thank you.